All right. Let's start the session. So yeah, I think we're all here for the second session of data structures and algorithms. Thank you all for joining in. So I have Rex Roy with me, who is a member of technical staff in VMware. Thank you, Rex, for accepting our invite to be the speaker for the day. So quick background about Rex. So he's a software engineer with around 6+ years of experience, and he always aims at delivering high quality code and building distributed systems. And of course, he's a fun loving person who is kind of passion driven in doing all these. And I think he would be the perfect fit for today's session. Thank you, Rex. Thanks for your time. And yeah, over to you.
Hey, thanks, Pavitra. Thanks for joining. Let me quickly share my screen. Let me know once it is visible.
Yes. Yeah. Good
Yeah,
to go.
just a minute. Hey, hi everyone. Thank you, Pavitra, for the introduction. This is Rex. I'm a tech lead in VMware's subscription and billing team. So in this session, I'm going to cover a simple and a basic data structure, linked lists. So as we all know, in data structures, there are two types. One is your linear and non-linear. Linear is basically the data is arranged in a sequential manner. The examples are your array, stacks, queues. Okay, linked list also is also a linear data structure. Non-linear is nothing but your graphs and trees. Okay, with linked list, the memory allocation is dynamic in nature. It allocates memory then and there is required. Okay, so linked list is simple. It has a group of nodes in a sequential manner. So each node has a data and an address to the an address of the next node. Okay, basically it's a pointer which points to the next node. So here's a sample singly linked list. Okay, where you have a sequence of nodes 10, 20, 30, 40, and 50. So each node has a data and it has a address which points to the next node. So basically 10 points to 20, and node 20 is in the location 1, 2, 3, 4. Okay, similarly 20 points to 30, and 30 is in the location 2, 3, 4, 5. Some of the real-time examples of linked list are your Spotify playlist or any kind of playlist, right? Where you navigate between your switch between your songs, okay, front and back. And also once you reach the last song of your playlist, right? And if you hit next, it starts to it goes to the first song of your playlist. Okay, this is basically an example of a circular linked list where the last node points to the first node. Okay, and the next one is your web browser. In web browser, we have all seen front and back pages, right? So once you go to the next page, okay, there'll be an arrow mark here where you can navigate to the next page and the previous page. Okay, this is an example of doubly linked list. Okay, and also linked list is a basic structure, okay, and is being implemented in various other data structures like stacks. Your heap implementation, heap uses linked list for the internal implementation of heap. Sorry, hash map. Sorry, my bad. So before I go to the implementation of linked list, I just want to show the differences between an array and a linked list. Okay, so in an array, the size of the array is fixed. Okay, first you allocate a size of an array, and then you go and do the manipulations, right? Okay, so if you have consumed all the spaces in an array, then it's done, and it array takes up a contiguous memory location. Okay, so you need a contiguous memory for allocating an array. Okay, while linked list, as I told you earlier, the memory allocation is dynamic. Okay, and the memory is not contiguous. Okay, you can the nodes can be in any location in the heap memory. Okay, so the next one is in array, the insertion and deletion of an existing element is an expensive operation. Let's take this example out here where you have a sorted array which is 10, 20, 30, and 40 and 50 in an array, and assume that you want to insert element 15 after 10. Okay, in this case, what will happen here is you're basically switching all the elements right from 20 to 50 by an index, correct? So assume that you want to insert another element 17, okay, after 15. In this case, you'll be again moving all the elements to the next index, okay. This is the same case for deletion as well. If you want to remove 20, then you have to bring all the elements from 30 to 50 by an index prior to it, okay. So which is an expensive operation, okay. In case of linked list, it's a constant operation, okay. It doesn't take much time, okay. Basically, these are your sequence of nodes. You have 10 to 15, okay, and you want to insert 15. In this case, what will happen here is you basically unlink the pointer which 10 points to and point it to the new node, and the new node will point it to the next pointer which 10 was previously pointing to, okay. Any questions so far?
Guys, feel free to unmute and ask your questions, or you can even post it on chat, so we'll be able to answer it. Good so far, Rex. Good to go on.
Yeah, sure. So searching an element takes often because you have to first find the element in the linked list, but insertion and deletion operation takes a constant time. Okay. So in linked list, there are three types. One is your singly linked list, doubly linked list, and circular linked list. Uh, we have been seeing singly linked list as of till now. Okay. A single linked list will have a node which has two segments. One is your data and the pointer to the next node. Okay. And it will have another pointer called head, which will point to the first node of the linked list. Next one is your doubly linked list. In doubly linked list, a node will have three segments. One is your data, and the next two segments are your pointers to the previous node and a pointers to the next node. In this example, right, you have 20. 20 has a previous pointer which points to the previous node 10, and it has the next pointer which points to the next node 30. Okay, and you will have two other pointers which points to the starting of the node and the ending of the node. The first node's previous pointer will be null, as well as the last node's next pointer will be null. It will not point to anything else. Okay. The next one is your circular linked list. Okay. In circular linked list, you can implement circular linked list using singly linked list or doubly linked list. Okay. The thing here is the last node in the list will point to the first node of the list. Basically, the last node's next pointer will point to the first node of the list. This is the example for uh, your playlist. Okay, so your last song in the playlist, if you go hit next, it'll start with the first song. Okay, and also you basically use a linked list against a array list when you are doing say multiple modification, or like if you're doing many insertion or deletion operation, right? In those cases, you will prefer linked list over an array list. Okay, and linked list is faster when compared to an array list. Any questions?
Rex, one question.
Yeah,
So can you give us example, like you gave the example of circular linked list, like singly and double in real life, like if we see it
yes.
or if it
So for a single linked list, it's your playlist or your image viewer, right? Okay, when you're in your playlist, okay, when
Mhm.
you when you want to go to the next song, you basically click the next arrow mark, right?
Right,
Okay, and it moves to the next song. Okay, when you select the uh, previous arrow mark, okay, it will play the previous song which you played. Okay, and when you go to the end of your playlist, okay, and you select a next, it will go to the first song of your playlist. It's basically
right,
a round robin version. Okay, and another example can be your operating system's allocation time, right? When there are multiple processes, Okay, it allocates CPU time based upon the round robin fashion.
Okay, so this is for circular linked list, right?
Yes, this is a
Yeah.
circular linked list.
Okay, so
For
about single and double.
doubly linked list, your web browser, right? In your web browser, let me take an example over here. See here, from this page, I'm going to the other page. Okay.
Right.
So here, this is your last node. This node will not have any other pointer.
Got it.
Okay. You can go to your previous node. From this node, you can go to the next, the other node which you went. Okay. And if you go to the first node, this will not have any previous pointer.
Got it.
Okay. Sure.
Okay, thank you.
Thank you. If there are no other question, let me go to the implementation of the singly linked list. Okay, let me move. Just give me a minute. I'll just connect to my pouch. Hey, sorry for the interruption. I was connecting to my chargers.
Sure, no worries.
Okay. Let me initialize the node class first. So this is going to have two segments. One is your data and the other is your next pointer. I'll have a constructor to assign the data value. I'll have an instance variable for singly linked list, which will be my head pointer, which will point to the first node of the linked list. Okay. So now let me insert a node to the end of the list. Okay. First, I'll I'll take a data, and in this list, there's no nodes, right? So here, this is going to be my first node. So I'll have a check here. Okay, prior to this, I have to instantiate the node. Now I have a node, and as this is going to be the first node, I'm checking if head is equal to null. If head is equal to null, then it's going to point to the node and return. If not, what I'm going to do is I'm going to loop to the last node where the current node's next pointer is null, so that I can add the new pointer. I can add the new node to it. I'm referencing the current head node. In this use case, right? So basically, assume that this entire list is present. Okay, head is pointing to the first node. I have referenced it to a current node. I am just looping through it till I reach a place where the current node's next pointer is null. Okay. Once I reach the last node, here what I'm going to do is I'm going to associate current dot next is equal to node, and I'm going to return. Okay. Let's check this one. I'm going to write a method to print the list. Any questions here? Basically, 10 will be the first node here. Okay. So here the head will be null. Hence, we are associating the pointer node is pointer head is going to point to the node. Okay. While for the second element 20, the head will be already be present. Okay. We are referencing head to the current pointer, and we are looping it till the current pointer's current's next pointer is null. And then we are just associating we are just pointing the current pointer's next node to the new node. Any questions here?
I think we are good, Rex. Yeah.
Sure. Let's see how we can insert it at the beginning of the node. I'm going to copy these steps because if this is going to be an empty list, then this is what we are going to do. Okay. We are going to point the new node and assign it to the head. Okay. If not, what we are going to do is we are going to point the new node's next pointer to the head. Okay. And we are going to point the new node as the head. Let me insert element 5. Any questions here?
No, Rex.
Okay. So the next one which we are going to perform is inserting after a specific element. Say you want to insert 15 after 10. Okay.
So, Rex, just one question I had, like suppose before you plan to create say a program or a web app, how do you decide which one do you want to make, like singly, doubly, or circular? If you don't know the scenario, if you don't know,
It's based upon the use case, right? Okay. So if you take in Java, right? In Java, there is a inbuilt class called LinkedList. Okay. And that implements your doubly linked list.
got it.
Okay. It is based upon your use case.
So anything about like efficiency or like storage or something that we consider, like for very heavy app, we cannot make this memory, something like that, do we consider, or just based on the use case?
It's not like that, Shubhashri. So it's basically it's based upon your use case, whatever you're using it. Yeah.
So, Rex, a quick recap. So, till now you have done insert at begin, insert at end. As in, first you did insert
Yes.
at end for 10, 20, 30.
Yes.
Now it's at the beginning, which is 1 and 5. So now we'll be
Yes.
seeing how we'll be
Inserting
inserting
after
after
an
an
element.
technically
Yes.
at any point, wherever we need, we have to insert
Exactly.
it. Yeah.
Yes.
Yeah.
Yeah.
Yeah. Got it.
So here I'm going to take two inputs. One is your element. Okay. And the next one is your data, which you are going to insert. I'm going to create a node here. Now I'm going to reference the head pointer. I'm going to check if current is not equal to null, because assume that there is a case that where you're giving an element that is not present in the list. Okay. Current dot data not equal to. I'm going to loop to the element after which you are going to insert. So in this case 10. So now my current pointer will be at the node 10. What I'm going to do is I'm going to associate nodes next to current pointers next. So I'm here. What I'm going to do is I'm first associating current pointers next to the new pointers next. Once it is done, it's a simple task now. I'm going to associate current pointers next to the new node. Now let me insert. Okay, it got inserted prior to it. What am I missing here? I have the current pointer here.
Hey, Rex, while you're checking, I have a question. So,
Yeah.
yeah, this is Ashok here. So, um, it is like, say, as you said, it is like case to case basis as to where I have to put this specific value, right? So, in your case, you have defined one function and where you're putting the element as 10 and you're expecting the value to be coming immediately after the 10, inserted after the 10th element. right?
Sorry, Ashok, can you repeat it? I
Now, what
missed
I'm
your
saying
question.
is like here you have defined a function called insert after an element, where you pass
Yes,
the element as 10 and you're expecting a value to be inserted between 10 and 20 as 15. So
yes,
so I can write any logic as in I can say third position or fifth position, or
yes, you can do
for
it. Yeah.
every fifth
What you
position
can
that
do
will
is,
be
yeah,
used.
yes, you can do that. Yeah. If it's going to be a after a specific pointer, right? I mean, after a specific place, right? Then you are going to do a iteration, basically.
Yeah. Okay. But from a
Yeah.
data structure standpoint, how do you think that the
Yeah.
a singly linked list is going to be optimistic over a regular list or an array? As in, like, how can I,
Can you come again?
from a data structure standpoint,
Okay.
like how do I justify saying my singly linked list is more optimistic than a regular list or an array? In terms of what, like in terms of searching or sorting, or
In
how do I
in terms of
like?
insertion and deletion, right?
Mhm.
So
Okay.
as I explained to you in the previous slides, okay. So what happens is when you want to insert a new element, if you use an array, okay, then it has to move all the places to the it has to move all the places
Shift.
to the next
It
instance.
basically shift to
Shift
the next
basically.
one.
Okay.
Okay.
Yeah. In this case, you're basically doing a linking and unlinking, right? Okay. Basically, what I did here is like instead of while I used an if. So hence it has moved to the first position. So here, if you see, now I have inserted after 10. Let me insert after 15 here or 20. Let me insert 25. Okay. After
What was
20.
the fix that you did to, like, there
So
was an
what I
issue?
did is here I have given if instead of while. I mean, in a flow, I
Okay.
have given if.
Okay. Okay. Sure. Sure.
Yeah. Sure. Any questions here?
Yeah, good so far, Rex.
Okay. The next operation which we are going to see is your delete operation. Here we are going to take an element which you are going to delete. I'm going to assign the current node the reference of head. So here I'm going to check if current.data is equal to the element. That is basically if the first element is the data which you want to remove. Okay. In that case, head is going to point to head.next and return. Okay. If it's not the first element, then I'm going to find the element which I'm going to delete it. So currently we have 1, 5, 10, and 15. Okay. Assume that I want to delete the element 15. Okay. In that case, I have to stop my iteration at 10. Okay. Hence, what I'm going to do is I'm going to check while current.next.data not equal to the element. So now what will happen is my current pointer will stop at the place 10. Okay. So assume that there are no elements after 15. Okay. So here what I'm going to do is I'm going to point current dot next to current dot next dot next. So it's going to point from 10, it's going to point to null. Okay, I'm going to return. Same will be the case for 10. If you want to remove 10, so my current pointer will stop at 5. Okay, and it will point to the one which 10 is pointing to. Say, let's remove, okay, the element 1 first. Okay, 1 got removed. Maybe let me remove the element 25. Got it?
Hey, can you go to the code?
Yeah, sure.
Yeah.
So basically what I'm doing is I'm creating a reference, okay, and the reference is going to point to the head. Okay, I'm checking if the first element is the element which you want to remove. In that case, what I need to do is I need to point my head to the next element, correct? So if the first element is going to be my element which I'm going to remove, then head is going to point to head dot next. Head dot next is nothing but your fifth position. Okay. If not, what I'm going to do is assume that I want to remove the element 10. In this case, I'm going to stop my current pointer at the position 5. So here, what it's going to check is current dot next dot data. So this is, assume that this is my current. I'm going to check if 5 is 10. Okay. If not, I'm moving it to the next pointer. So when I'm in 5, current dot next dot data is 10. Okay. So I'm stopping it over here. Here, what I'm doing is I'm going to delink this one. Okay. And I'm going to point current dot next to current dot next dot next.
Okay.
Sure.
Sure.
So these are the few operations in a singly linked list. Okay. Let me go through doubly linked list here. So doubly linked list is similar to singly linked list. Okay. But the difference is you will have 2 pointers. Okay. Which will be your head pointer, which will point to the first node, and you will have your tail pointer, which will point to your last node. Okay. And each node will have uh, two other pointers, previous and next. This is similar configuration where I am like creating a node. Data is going to point to the data, and previous and next pointers are going to be null. Okay. So when I want to, this is one is inserting at the end. Okay. When I want to insert an element, what I'm going to do is I'm going to check if the head is null. That is, if it's going to be the first pointer, first node in the list. In that case, both my head and tail will point to the first node. If not, what I'm doing is I'm looping to the last element where the current dot next is going to be null. Okay. And here I'm going to set current dot next pointer is going to the new node, and node's previous pointer is going to be the current node. And my tail is going to point to the last node. See this example here. Okay. Any questions here?
Do you have any illustration for double linked list?
Can you repeat it? Like your voice was low.
I'm asking if you have any illustration, like how you have for linked list, single linked list. As in, like, what is the key difference between single? Maybe I missed what you said.
You're asking the key differences between a singly
Yeah.
linked list
Yeah.
and the
Yeah.
doubly linked list.
Yeah.
So singly linked list will have a single pointer which will point only to the next node. Okay. While a doubly linked list will point to the previous node as well.
Okay. Okay. Sorry. I think I missed it. You said it again. Okay.
Yeah. So
So
a
maybe
doubly
I
linked list
think
will have references to the previous pointers as well, previous nodes as well.
Got it. Got it. Got it. Got it. Yeah, makes sense.
so. Yeah, Rex, I think which operation would be easier this way, as in find or something will be little easier than singly linked list, right? Since you have a previous and a next pointer when you traverse
Uh,
through front and
yes,
back.
in most of the applications we'll be using doubly linked list.
Right. Yeah.
Singly linked list provides the foundation. Yeah.
Right.
Okay. So the next one is you're inserting after an index. Okay. Similarly, if it's going to be if it's going to be the first node, then we are going to make the current node point to the head. Okay. And we will loop to the last node. I mean, loop to the node where after which you need to insert the data. Okay. Once you go over there, let me take this example. Okay. So assume that this is the node after which you need to insert the new node. So now what you need to first do is you need to associate the new node's previous node to the current node. Okay. This is what we are doing. New nodes. Okay. New nodes previous is going to be your current node. And new nodes next node is going to be your current nodes. I'll call it as C here. There's my current nodes. Current nodes next node. Okay. So the next thing which I'm going to do is I'm going to map the current nodes next as the new node. Okay. So if current node dot next is not equal to null, then current node dot next is equal to the new node. Okay. And you can associate new node dot next previous is going to be the new node, or you can do the other operation as well. Okay. Where you can point current nodes next dot previous is going to be your new node. Current nodes next dot previous is going to be a new node, and current node dot next is going to be your new node. In case if you want to insert in the last position. Okay. In this case, what will happen here is your current node dot next node is going to be this one, and your node dot previous node is going to be your current node. Please excuse my diagram. Okay. And you're going to point tail as the new node. So this is going to be my head. This is going to point to my tail. Any questions here?
Yeah, I think we're good, Rex.
Okay. The last operation is going to be your remove. Okay. So here they are going to provide a data. Let me open my slide here. Say that you want to remove the position 20 here. In that case, what will happen is you will first go to the data, the node where you're, to the node which you want to delete it. Okay. Now you are going to make current node dot previous next. Okay. Current node dot previous is going to go to this node. This node's next is going to be your current node dot next. Okay. So you are going to point this node to this node. Okay. And if current node dot next is equal to null, in this case, if it's the last pointer, okay, what you're going to do is you're going to make that as the end node or the tail node. So I'm just assigning tail to the current node dot previous. Okay. If you're going to remove this node, okay, then you have to make this node as the tail. Okay, that's what I'm doing out there. The next one is if not, current node dot next dot previous is equal to current node dot. So current node dot next dot previous is equal to current node dot previous. So you're basically associating these two. Any questions?
No, Rex.
Okay, let me execute this one. Inserting after. And I'm going to yeah. Any other questions? Nice.
Guys, you can unmute yourself and ask any questions if you have.
I know this is a simple implementation, but if you have any question, you can post it.
But I think Rex, it was really good. I think this is the need of the hour. So a live coding and have executed and showed us.
Sure. Thank you then.
Okay. All right. Shubhanjali, you have anything?
Thank you all. Yeah, I think Rex, it was a wonderful session, and especially, you know, with theory and just PPT, it looks very easy, but unless it is put down in code, then the actual understanding becomes better. So thank you so much for, you know, showing us
Hey,
and
thank you so much.
demonstrating that.
Yeah.
Thank you
Thank
so
you.
much. Thank you everybody for your time on a Friday evening. It was a wonderful, very knowledgeable session. And once again, thank you so much, Rex, for such a wonderful session. I learned a lot personally, and I'm sure everybody else also here learned a lot. So guys, we will have more sessions on this series coming up. So please stay tuned. Also, we have the recording of this session. So these will continue. This DSA series will continue. So please keep logging in to have a continuation of the series. Also, we have Women Who Code Connect conference, which is the theme of which is Craft Your Career. It starts on 9th. So please do register there as well. Wonderful sessions coming up. Please stay tuned. Join our meetup page. The link of which would be, I think, in the chat. We would try to put it in the chat. And I think, yeah, thank you so much for your time on a Friday. It was
Thank you.
really
Thank you.
nice.
Bye.
Thanks, Rex. Thanks all. Bye.
Thank you, everyone. Bye.